Hey folks, this is a follow-up to an earlier video where I kind of went over some different types of electric fence testers, the pros and cons, blah, blah, blah. And I promised in that video that I was going to make a video about using a fault finder to actually find a fault in a fence. So I kind of set up a little scenario up here in front of the house. I'm also going to kind of demo a little bit of what to do if you don't have a fault finder, if you just have a voltmeter, older or cheaper type of fence tester. So we'll do that as well, but let's go ahead and get into it. All right, give you a little bit of an orientation here. The charge on this fence comes from this way up to this point and keeps going on that way, and then it also feeds this little 2-strand divider here. This is just 3-strand high tensile. So let's go ahead and say that we're going to test the fence right here, and I'm just going to hit it right here, and I'm going to go, oh boy, 3.1 kilovolts. That's basically nothing. That's definitely, we have a problem, Houston. So we're going to go start trying to find it. So in this particular setup, this middle wire here is what actually feeds this fence line going that way. And then the top wire keeps the charge going on to future fences. But I'm noticing on this top wire, that's not very much amperage draw. That's a pretty low number. Like, yeah, there's a little bit. There's probably a tree touching it or something someplace. But that's not very much, not for that much voltage loss. What if we come over here and check this middle wire that feeds into this gate here that carries the charge that way? Oh boy, 52, 49, 48, pretty high amp loss. Now, what I can do, let's say I don't have a voltmeter and it's telling me I don't know what my amp draw is, or excuse me, don't have a fault finder. I just have a voltmeter and I want to know what my amp draw is, or approximate this effect of going, okay, it's that way. The problem is that way. All right, what I can do is ignore, all right, we got 3.5 volts. All right, what if I disconnect this gate? All right, because that's carrying the charge there. All right, now we got 10 kilovolts. We're back up to normal. So yeah, the problem is that way. We removed the fault by disconnecting it. So that's kind of the basic. I'm not going to do that the whole way through, but that's the basic way to do this if you don't have a fault finder. So we can walk along this fence here and we can check it. Let's pretend that we don't want to do that though. Let's pretend that this fence goes in a loop out someplace and we don't want to go walk the whole thing. Maybe it goes out in a loop and it comes back around to over here. And we can go here and I can see, oh, look at that. We still got 58 amp draw on the top wire. Let's check the bottom wire. Almost no amp draw on the bottom wire, 2.2. So the problem is not on the bottom wire on this particular fence line. And the problem is still that way on the top wire. It is not that way on the top wire, because we're still seeing that amp draw. All right, and we'll walk the fence here. So we're right up in front of the house here. This is obviously a manufactured scenario, but hopefully it's good enough to get the point across and give you a little bit of an idea. Remember, if you're using this style of fault finder, you need to put your thumb on that little divot or you will not get accurate readings. No, it will not shock you. You see me doing it. This isn't a prank. If someone's trying to play on you, it will not shock you. All right, so we're at this gate here. Again, we could disconnect the gate and yada yada. Or I'm gonna check it one more time here maybe. Okay, oh yeah, the amp draw is definitely that way. So we didn't miss it. We didn't walk by and miss a broken insulator or something like that. And this gate feeds over to here. And over here, the gate, little insulated wire, goes up to the top wire up here. So what we can do is the charge is there and it goes that way and it goes that way. All right. What if we check over here? Okay, there's a little bit of an amp draw that way, but not much. Not much. Remember, we were seeing like 60. If I go over here, it's nothing. You know, just go a little further away from the jumper there. All right, I go, it's really good because it's sparking there. Go right there. Oh yeah, 57 amps. All right, that's what we're looking for. So it's this way. All right, ignore the tree branch that fell down. I'll clean it up sometime. Don't worry about it. tree branch to come down. Oh boy, we get over here and let's pretend we didn't see this. Just use your imagination. Let's pretend we didn't see that. We walked by, you know, there was a broken insulator someplace and we walked by it and didn't see it. We come down here and we go, oh boy, there's no amp draw anymore. So what happened there is we got past it. The amp draw is right here. Get in front of it. There you go. And that's how you can kind of isolate it down to get the location. Get specific strand that it's on a multi-strand fence, get a location, make a decision point at multiple jumps like that. Saves you from having to disconnect gates, retest the fence, and reconnect the gate, blah, 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 at gates and stuff like that. Or even be able to do that same process that you would do at a gate. You can do that anywhere just by stopping and checking it. So super duper handy. If there is one piece of equipment that if you're getting into electric fences for any reason that you should get, it's one of these. If you absolutely can't afford one of these, you know, check out my other video. There is like a couple lower tiers of fence tester that I do have and do use that are useful still, but not as useful as this. So.